Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we are looking at electromagnetic radiation. The problem that we're given states the wavelength of a red traffic light is 655 nanometers. What is the frequency of this electromagnetic radiation? So, in looking at this, we need to figure out what equation to use, and the simplest one to use would be our equation for the speed of light, which is simply that the speed of light, c, is equal to lambda, which is our wavelength, mu. Now, the speed of light in this case is in a vacuum that always has to be stressed. So we're looking at ideal conditions when we're looking at this problem. Now, as far as the constants are concerned, we have c, which in this case will be equal to 3.00 times 10 to the 8th meters per second. And immediately you can see that there is a disparity between the units given for the speed of light and the units provided for the wavelength, or lambda, of our red traffic light. So we're going to have to do some unit conversion. You can convert either one, either c or lambda, to the either meters or nanometers. So I'm going to choose to convert lambda into nanometers. It's a relatively simple calculation. So lambda is going to equal 655 nanometers times 1 times 10 to the minus 9 meters per 1 nanometer. Your nanometers will cancel out, and you'll be left with meters, again using dimensional analysis. So lambda is actually going to equal 6.55 times 10 to the minus 7 meters. So now we have two knowns and one unknown. We want to solve for the one unknown. And to do that, we have to get mu by itself. It's the character that kind of looks like a V. So we're going to divide both sides by lambda. And this will get mu by itself, giving us mu is equal to the speed of light over the wavelength of light. So plugging in our values, we get 3.00 times 10 to the 8th meters per second over 6.55 times 10 to the minus 7 meters, and that will get us our frequency, which when you do the arithmetic out, you'll find that meters and meters cancel each other out, and you're left only with per seconds, otherwise known as hertz, and you get 4.58 times 10 to the 14th power per seconds, which is also equal to 4.58 times 10 to the 14th power hertz, depending on what units they want you to use.